just being able to read a graph and what's happening. So when comparing two quantities, straight lines are used to indicate a constant change in the relationship. Curves are used when the rate of change is not constant. Horizontal lines are used if one quantity is not changing relative to a change in another quantity. Okay. Basically, all you're looking at, and how I teach this more or less in physics, would be something like this. Let's say you have a time here, and this is your distance. Okay, so let's go back through actually, and let's talk about your axes as well. All right, so the vertical axis, oh, I did that completely wrong. Your horizontal axis is your x-axis. Your vertical axis is your y-axis. Now, most times, we label like this. Okay, the x-axis is your independent axis. That's the one that can change and fluctuates. And how it changes changes what the y does, because the y is dependent on what the x is. So we need to, when we talk about an independent and dependent axis, the y-axis will be your dependent axis. When you write out the equations, which we're going to get into over the next 2 units, the y will always be equal to something that happens to the x. Okay? All right. Now, if you are walking away from the school, let's say the school is your home base, and you're walking away from it. At 0 seconds, you start in front of the school. Now, this can be in any direction. So if I walk at a constant rate, maybe I walk at a constant rate towards the hospital. I'm getting away from the school. I'm going at a constant rate. Okay? Now I get to the hospital. And at the hospital, I'm going to stay and get checked out for something, whatever, visit somebody, who knows. The time keeps going, but the distance that I've traveled doesn't keep going. All right, the distance that I traveled, I'm still at the hospital. So that distance, let's say hypothetically, is 300 meters from the school. So let's say that that's 300 meters. Now these are all hypotheticals. I'm just putting them on paper so that you can see it. Now let's say I did what I had to do at the hospital, and I'm going to be late for class, so I'm going to run back to the school. So I might run, and I may go at a faster pace than I was walking to the hospital. So the walking part of it has a slow incline. The running part might be a little steeper. So let's say I'm able to run at the exact same pace, and I keep that pace, and I get back to where I started, which is at the school. So according to the distance, if this is the school right here, according to that distance, if this is the school, all right, the school is my home base. The distance is the y-axis. This tells you where you are in relation to where the school is. You were moving away from the school at a constant pace. You stayed wherever you were for a given amount of time. The time keeps going, it doesn't stop. And then you ran back to the school, so you went a lot faster, so you had a steeper line. That's just a simple relationship between distance and time. Okay? So as you get into grade 10 physics, if you have or you haven't yet, I don't know. But when you get into grade 10 physics, you're going to study the relationship between distance, time, velocity, and maybe even acceleration. So acceleration it could possibly be different than this. And that is, those are straight lines. But those straight lines indicate that I'm moving at a constant pace. But what happens then if I start my car? I'm at a stop sign here and I start my car. Do I go at a constant pace? No. I accelerate. I start slow and then I get going faster, yeah? So to show that on possibly a velocity time graph, so let's say this is my velocity here, this is my time over here, I might do this, which creates a curve graph. All right. Now, we don't study curve graphs until we get into grade 11. You might study it in grade 10 physics, though, possibly in your grade 10 science class. Okay. So the curve represents an acceleration that's not moving at the same rate of change. That's hence the curve. All right. Now, the first example that's given to you in your book, travel guides often provide climate information such as the graph shown here. Travelers can use this information to plan their trips. All right, so I have two separate locations, and the average temperature is given in Fahrenheit. So what's the first thing that you can maybe establish from the fact that it's Fahrenheit?
Not from Canada.
Not from Canada. That's exactly correct. Everywhere else in the world uses Fahrenheit except Canada, pretty much. All right. So not from Canada. All right. So there's the first thing that I can ascertain from the actual graph itself. All right. So now it says, what might the curves represent? Well, I think I indicated it possibly, but maybe I'm wrong. So what could those curves represent? The heat throughout the year, the temperature throughout the year? Yeah, okay. Now, is that, well, what type of temperature are you thinking here? Is it the average temperature? No. Is it the highest temperature? What do you think? What are you looking at?
Lowest.
Highest?
Lowest.
Lowest temperature? Well, it could be that too, I suppose, yeah. But if you're trying to travel somewhere, what do you want to know? Let's say you're traveling from Roblin in January. Are you more than likely going to go somewhere colder than what Roblin is, if that's even possible?
Not likely.
Not likely. So what am I going to look for? The hottest place. All right. So now looking at that chart, at that graph, okay, it shows maybe the hottest temperature, but what do we know about Fahrenheit? What's 0 degrees Celsius in Fahrenheit? Do we know?
28 or something.
What's that? 32.
32.
Okay, so let's look at the January temperature for both of these guys. For both of these. One is close to 0 Fahrenheit, so maybe close to 5. The other one is maybe around 25 degrees Fahrenheit. Are those warm climates?
No.
No, they're not. Right? Those are not very warm. And that's what you'd be looking for. Okay? So where might that be located? Can that indicate possibly where one of those are located? Yeah? Whereabouts do we think? Yeah. Yeah, 100%. Probably somewhere close-ish to Canada, right? Because those temperatures, one is actually below 0 degrees Celsius. Actually, they're both below 0 degrees Celsius, right? So they're coolish. All right. Now they're maybe not at 30 below, but they're probably 10 to 15 below. All right. So it says, can you think of more than one explanation? Would the points on the curves represent for each of your explanations? All right. So what would they represent? Well, they might represent the average temperature for those months. They could represent the highest temperature for those months. We don't know. But we could have an idea of what they're going to look like. And does it make sense that it peaks in the middle?
Yeah.
Why?
Because those are hotter.
Summer.
In the summertime.
Those are your summer months, right?
Yeah.
So we know that then means that it's for sure above the equator. Correct? Because the summer months in Australia or New Zealand or south of the border are when?
All year.
Well, they're warmer all year, possibly, yeah. But their actual summer months are Where is it?
It's December.
December, January, those are their summer months. Okay, so we can tell from that picture. All right. I don't think there's much more I need on that page. All right, I'm going to go into, I want to look at page 118 today. There will be, Thursday I'll be away from class. Friday I should be in class. So I want to just make sure that we get through a few of these things just to make sure. Okay, relations can be represented in a variety of ways. You can use words, equations, tables of values, ordered pairs, or graphs to describe relations. All right, first of all, I said that there was a relationship here. There is a relationship between the distance and time. Over here, there's a relationship between the velocity and time. So when you have a graph, you are looking at a relationship between two different variables, so to speak. All right, two different things occurring, let's put it that way. All right, so a relation can be one of two things. You don't have to write this down, but we want to understand. There are two types of relations that we are going to study. The first and the primary one we're going to study in this class is linear relation. What does that mean? Okay. What's the line? What does that linear mean, actually? It's a line, straight line. Okay, so that's going to be a straight line one. And then there's going to be non-linear ones. For example, the one that I used with the velocity and the time. So non-linear. So there's linear and non-linear. Now we're going to look at a relationship in which this is a discrete linear relationship. When it's a discrete linear relationship, it means that they are not connected. All right? And I'm going to show you, I'll show you an example of both in a second. And then this is also going to be ones that we're going to look at, which are continuous. Okay? So we have discrete and we have continuous. And we have the same for nonlinear. But the nonlinear ones we don't study until grade 11. Okay? So I'm not even going to go down that path. All right. So difference between discrete and continuous to give you an idea. A discrete graph would look something like this. All right. Let's say I wanted to, let's go with, what can I purchase? Whatever. Bags of candy. Okay. And let's say the bag of candy is $2 each. All right, so if I would purchase one bag of candy, how much is it? $2. So I put a dot right there. If I purchase 2 bags of candy, how much is it? $4. And 3, 4, and 5. All right. Now, the reason I haven't connected them is because I can't buy a part of a bag of candy. So anytime I buy something that's whole, I can't buy a part of it. Like let's say I buy a hamburger or a hot dog. All right. I can't buy a part of it. So I don't connect between the whole numbers so that there's decimals. You follow what I'm saying here? Okay. So if I drew a line, that would imply, if I drew a line through these like that, which I can't, that would imply that I could have half a bag of candy and it would cost $1. Doesn't work like that. Okay? This is called discrete. Discrete means I don't have a line. That's discrete. Okay? Now, let's look at something else. See if they got an example that I can use in here that I want to use. All right. All right, here's what I'm going to do now. I'm going to use an equation. Let's do that. All right, so there are what does it say here? There are 1, 2, 3, 4, and 5. There are 5 ways in which we are going to look at relations. We are going to talk about them in terms of words. All right? So an example of that is you are working a job right now and you make $15 an hour. If you work 10 hours, how much money do you make? $150. Okay? So we could write that out in words. The amount of hours worked times the $15 per hour. You get that. Using an equation, the wage, the cost of the wage that you make. The wage would be the W, and it would be dependent on the number of hours. So X could be your number of hours. So W equals 15X. All right, so this would be wage is equal to 15 times, maybe I'll put H. So wage is equal to 15 times H. So if you work 2 hours, how much money do you make? $30. You work 3 hours, how much money do you make? $45. Okay, so one of the things is that a discrete or is that continuous? Okay. Now, something to learn. Do you get paid for part of your time working?
Yeah, well, it depends.
It does depend, doesn't it, Jackson? What do you think it depends on?
Like what the first contract was that you made with your boss.
Right. Okay. So, would it be fair that you only got paid for, let's say you worked an hour and 45 minutes, but you only get paid an hour? That wouldn't work, right? Okay. So, we could look at this and say, all right, well, this must be continuous then. Now, you may not get paid by the minute. Let's get that straight. You might not get paid by the minute, but you might get paid every 15 minutes you work. All right, that's sometimes how it's set up. And there's a part of the course that we do look at that. So we could call that a continuous one. All right, so at $15 an hour, if you work 4 hours, you work for $60. That's how much you earn. That's a continuous one because you can get paid for parts of an hour. All right, so that's the difference. Discrete means there's no solid line to connect that. Continuous means there's a solid line that connects it. Fair enough? Okay, that's all I have for you today. I want you to go through, you may need some graph paper. So if over the next couple days you can, I have some for today, but if over the next couple days you can find a way to get some graph paper, it'll help you because the next chapter 6 and chapter 7 is all on graphing. All right. Okay. Bless you. I'll shut that down then. I'm going to shut this off.